All right, I'm going to walk through a cliff type projectile motion problem. It may surprise you. We call them cliff type problems because they typically involve a cliff. In this case, here's you, and you have a raccoon that you're throwing off of this cliff. You're throwing him down into like a raccoon sanctuary, and you don't have to worry about it because 50 meters away from this cliff, you have placed your raccoon safety pillow for catching raccoons that are thrown off of cliffs. So in this case, I want to know, is the raccoon actually going to reach the raccoon safety net, or is this a terrible problem that depicts a horrible thing? So we'll find out. And to do that, we want to consider the starting condition. So you have projected this raccoon off of this cliff with an initial velocity of 20 meters per second in the horizontal direction. So you've launched it just horizontally, as one does with raccoons. Looking at our different variables, I have my initial and final x displacements, velocities, and the x acceleration, along with those same variables for the y direction. So even though you're just projecting this horizontally, we know it's going to succumb to gravity and it's going to arc downwards and hopefully reach this 50-meter point. Therefore, I need to break this down into my x and my y. There's some things that we know right off the bat, though. So for instance, I know the x displacement initially is 0 meters. I hope the final x displacement is going to be 50 meters, but we'll find out. The initial x velocity, actually, I know is 20 meters per second because as I said for you, it's projected horizontally, so it's not being launched up or down. I also know that the x acceleration should be 0 because we're not dealing with air resistance or anything like that. So if I have 0 meters per second squared of x acceleration, that means that my final x velocity should also be 20 meters per second, meaning that when the raccoon does reach the safety pillow, or hopefully he reaches it, he'll still have an x velocity of 20 meters per second horizontally, which is good. It'll give him a good running start as he goes off to enjoy the raccoon sanctuary. For the y variables, it's a little different. So I know it's starting 30 meters off the ground, and so I'm going to plug in 30 meters here. Now, for you personally, if you prefer to consider the starting point 0, that's fine, as long as your final y displacement is going to be 30 meters less. So I'm going to say 30 meters is where I started, and I'm going to end at 0 meters. You could put 0 here and end at negative 30. That's fine. Mathematically, it'll all work out because it's the change in displacement that really matters. For my initial y velocity, I actually know that that's going to be 0 meters per second because I said I projected the raccoon horizontally, or you projected the raccoon horizontally. We didn't throw it up or down. The final y velocity we know is going to be something negative. We don't know what that value is going to be yet, but we know it's going to be negative because the acceleration is negative 9.8 meters per second squared. Okay, so if the question is to find out, where does the raccoon land, then I'm going to need to know how long it's in the air, because if it's traveling at 20 meters per second for every second that it's flying through the air, if I know how long it's in the air, then it should be pretty easy to find out how far it goes. So we need to know how long it's in the air, and considering a projectile that's launched off of a cliff, as we may figure out, or we'll see in a video, or maybe we've already seen this in a video, it doesn't actually matter how fast horizontally you project something in terms of how long it takes to hit the ground. So whether you just reached your arm out and dropped the raccoon, or whether you threw it horizontally, that horizontal motion is not a factor in how long it takes to reach the ground. What actually matters is that 9.8 of gravity, because that's what's going to drive the object towards the ground, and it's going to determine how long it takes to hit the ground. If I wanted something to take longer to hit the ground, in the case of throwing it off of a cliff, I wouldn't throw it faster horizontally. Instead, what I might do is either get higher up, add a ladder to help you throw the raccoon farther, or change gravity, but that's less easy. So we want to consider the y variables when we're thinking about how long it takes for this thing to hit the ground. I can't use VATVO because I don't know what the velocity is, the final velocity, and I can't use the timeless equation because it's timeless. So I'm going to need to use the x monster, or in this case the y monster, and so I consider y equals 1/2 at squared plus VOT plus the initial y displacement. Got to remember, I need my y acceleration and my initial y velocity here, because we're just dealing with vertical variables. Can't mix and match between x and y since that acceleration is only affecting the y. If I solve this around, at first glance it seems really annoying if I'm going to solve for time. I have everything except for time, so that's nice, but quadratic equation is annoying and we hate that. But thankfully, luckily, we don't have an initial y velocity, it's 0. So this component of the equation goes away, and then this actually becomes a lot easier. And if we solve this for time, I'm just going to do some quick algebra here. If we solve this for time, we actually end up with that it is equal to the square root of the change in y over 1/2 of the y acceleration. So you can go through and do all the algebra there and practice that, but this is what we're going to end up with. And so if I do this, I know that my change in y is negative 30 meters, and I know that half of my acceleration is negative 4.9, and I should be able to solve for a time value here of about 2.5 seconds for the raccoon to hit the ground. So the next question is going to be, well, is 2.5 seconds the right amount of time for him to reach our raccoon safety catching net? And so knowing that it's in the air for 2.5 seconds, we can now find the range of the projectile, because if I want to find the x displacement, just go back to the x monster, 1/2 at squared plus VOT plus the initial x displacement. Again, this is the x acceleration. It's the x initial velocity. In this case, we have no x acceleration, so that goes away. We have no initial x displacement, so that goes away. And once again, very straightforward equation. So I have my range is going to be equal to VXO times t. So if my x is equal to 20 times 2.5, lucky raccoon, we got 50 meters. And so our range is going to be 50 meters. Your raccoon was perfectly safe, landed on its raccoon containment device or catching device or whatever I said. And here you go. He's happy. He also still has a horizontal velocity of 20 meters per second, but that's a different problem for a different day. So there's a cliff type problem for projectiles. This is one of several types of projectile motion questions, and all we really need to do as a quick recap is write out your variables, assess what you know from the story or from the given values, and then start piecing together what you can solve for. If you don't have time, that's almost always the first thing to get, because then that's going to let you solve for things like range or whatever you might be missing. So there you go, and hope that was helpful.